So today we're going to be looking at an exam question about Huntington's disease. Now these can be worth about 3 or 4 marks and they're dead easy, so I want to show you how to tackle it. The first point I'd like to make is at the bottom here we are given the alleles. So we've got a capital H here which represents the dominant allele, and we've got a lowercase h which represents the recessive allele. So with dominant, you just need 1 copy to get the disease. With the recessive allele, you need at least 2 copies. Now, obviously, we've been given the recessive alleles, so from that we can work out a piece of information quite quickly. We can see that these people here circled don't have the disease, therefore they must have 2 recessive copies. Okay, they must have little h, little h. Now we call double recessive alleles, we call them homozygous. Okay, it's when you have 2 of the same allele, you have 2 copies that are exactly the same. Homozygous. So we can say these people are homozygous recessive and they don't have the disease. So at this point you've probably got yourself maybe 1 mark, 2 marks if the examiner's feeling very generous. The next part is probably the more trickier part, and it's trying to work out what this person here, number 1, has. So we know they've got the disease, so we're trying to work out what combination of alleles they've got. Now because it's a dominant disease, we know they must have a capital H. However, we don't know if they've got 2 capital H's or 1 capital H. We don't know if they're homozygous or heterozygous. So let's do a little bit of trial and error and see if we can work out what this person is. So let's pretend just for the second that they are homozygous dominant. They have capital H, capital H. Now we know the mother is homozygous recessive because she's got little h, little h. So at the bottom of your exam paper, you could quite quickly plot a genetic cross diagram. So we've got the father there, capital H, and the mother there, little h, little h. And if we cross all of those alleles, we find that actually all of the offspring get the dominant allele. Now they get the dominant allele from their father there. So this tells us that all of the children would get the disease. However, when we look at the offspring from 1 and 2, we can see that actually here, these people on the line don't have the disease. They must have got a second recessive allele. So that tells me that they've got a recessive allele from their mother, but they must have got another recessive allele from their father. So we must assume that the father is heterozygous. He is capital H, little h. Finally, you might be asked about parents 6 and 7. Now, they both have the disease, but again, we don't know the combination of alleles. But we can look to the children here, and we can see that child number 11 has homozygous recessive, so they've both got little h, little h. This again tells me that they must have got those alleles from one of each of their parents. In other words, they've got a little h from their mother, a little h from their father. But because both parents have the disease, they must have a capital H there as well. So they are heterozygous, heterozygous dominant with the allele there. So finally here I've just made a couple of definitions. So obviously homozygous is when the alleles, or the combination of alleles, are the same. Heterozygous is when the combination of alleles are different. I hope you found this useful, and thank you for watching.